All right, ladies and gentlemen, so in this video, I'm going to help you work through the supplemental exam problems. So at least for my students, if you get this test, you are required to take it even if you exempt the final. It's a separate test grade for pre-AP students only. You must show all the work, and that's actually the whole point here. Problems without work will not receive credit. You may not use a calculator. And this video that I'm making right here is something that I highly recommend you spend some time with so that you fully understand how to solve these problems. Otherwise, the test will not be something that you can do. So let's get into this. In the first question, we have to solve by factoring. Okay, there's no leading coefficient, so we can just ask ourselves what two numbers add to be the middle coefficient, and those same two numbers need to multiply to be the final constant. So I'm thinking about the factors of 18. 6 times 3 is 18, and 6 plus 3 is 9. So if we write this down, b squared plus 9b plus 18 equals 0, then the factored form would be open parentheses b plus 3 close parentheses, open parentheses b plus 6 close parentheses, and that would equal 0. So that's the factored form of the quadratic. And the way that you find the solutions to the factors is by setting each one of them equal to 0. So this quadratic equation will have two real solutions. We subtract 3 from both sides here to get b equals -3. And we subtract 6 from both sides here. I guess I'll show this -3 for b to equal -6. So the solution to this quadratic equation is -3, -6. Okay, it doesn't matter what order they're in. This doesn't represent a coordinate or anything. So it's just C, -6, and -3. Okay. Now for number 2, we have to first make sure that we have all of our terms on one side of the equation, especially if they have a variable. So let me write this out. Trying to make it so where you can see what I'm writing as I'm writing it. Let me bring some more light in here. Okay. So we have -6r squared minus 4r minus 5 equals -7r squared. Okay, so to get these r squared variables together, I'll just add 7r squared to both sides of the equation. And on the right side, we get 0, which is what we wanted. Okay. And on the left side, -6r squared plus 7r squared is 1r squared, or just r squared. So there's no leading coefficient in front of the squared variable. Okay, just -4r minus 5. Now to factor this, we need to think of two numbers that add to be -4 and multiply to be -5. So you should be thinking of 1 and 4. All right, so one and 5 rather. Positive 1 plus negative 4 plus negative 5. I don't know why I keep saying negative 4. I'm staring at this number. So let me back up here. So we're trying to find two numbers that add to be the middle term and multiply by the last term. What they're going to be is positive 1 and negative 5, because when you add them together you get negative 4, which is the middle term, and when you multiply them you get negative 5, which is the last term. So when we factor this quadratic, all right, it's going to look like this. R minus 1, or wait, minus 5, and R plus 1. Okay? So now to get the solutions to this quadratic, we set each factor equal to 0 and solve. So I've got R minus 5 equals 0 and R plus 1 equals 0. If I add 5 to both sides, I get R equals 5. And if I subtract 1 from both sides over here, I get R equals negative 1. Okay, so I guess I'll write this in the solution form. Negative 1 and 5. This is how they want it. All right. So these are the two solutions. These are two real solutions. And remember, this is where this quadratic equation crosses the x-axis. It has a positive slope, so we know that it slopes up, all right, with a y-intercept at negative 5. And it crosses the x-axis at these two places. Okay, but we successfully factored and solved this quadratic equation. So it's D. Okay. Now in the next two problems, we do have leading coefficients greater than 1, so we'll have to use a different factoring technique than the one that we used in the previous two problems. First, we check to make sure that we've got everything on one side of the equation, and we do. Okay. Now, when you're working with a quadratic like this, we're going to have to factor by grouping. All right. We could use the quadratic formula, but that's not what it wants us to use in this problem. It does not want us to use the quadratic formula in this problem. It wants us to factor it using some other technique. And we're going to factor by grouping. So the very first thing we have to do is multiply 14 times negative 20, because when you factor by grouping, you start by multiplying the leading coefficient of k squared, okay? That's the a value in a standard form quadratic equation. You multiply this a value by this c value. This is the constant term. So over here in side work, we'll need to multiply 14 times negative 20. Okay, so our answer is going to be negative, but the multiplication will be the same. 4 times 0 is 0, 1 times 0 is 0, 4 times 2 is 8, 1 times 2 is 2. So we got negative 280 as the product of those two numbers. So what we're trying to accomplish here is to now find two numbers that multiply to be negative 280 and add to be negative 27. Sometimes it's helpful to set up a little table like this. You need two numbers that add to equal negative 27, and those same two numbers have to multiply to equal negative 280. Okay? When the numbers get bigger like this, it's important that we're really keeping track of our work. And so how do we find two numbers that add to be negative 27, and multiply to be negative 280. Well, um, what we could do is actually factor 280, right? So we're going to think of all the possible combinations of numbers that can multiply together to get, I should say, negative 280. Okay, so let's start with the obvious, which would be 1 times negative 280. We could also do negative 1 times positive 280. Now, the way I'm going to evaluate whether these are correct is I know that they multiply to give me negative 280, but what do they add to equal? And that's how we're going to eliminate them. If they don't add to be negative 27, then they're throwaway. So 1 plus negative 280 is negative 279. Negative 1 plus 280 is positive 279. So neither of those are 27, so those aren't the factors, right? So let's think of something else. How about 2 times 140, negative 140? Or negative 2 times positive 140. Those clearly won't work. 2 plus 8 plus 0 is 10, so this isn't divisible by 3, but it is divisible by 4 because 4 goes into 28 7 times, so 4 goes into 280 70 times, so I could do 4 times negative 70 or negative 70 times positive 4. I should probably keep these lined up better. Again, these don't add to be negative 27, so we start moving up. We can do 5 because it ends in a 0. 5 times, let's see, it goes into 28 5 times, and then it's 6. So 5 times 56, 5 times negative 56 equals 280, and then negative 5 times positive 56 also equals 280, but they don't add to be negative 27. How about 6? Is 6 a factor of 280? Well, 6 goes into 28 4 times with 4 as a remainder, but 6 won't go into 40, so 6 is not a factor. Let's see, 7 works. We have 7, and then we could do 7 times 40. So that would be 7 times negative 40 is negative 280, and negative 7 times positive 40, but those don't add to be negative 27, so we can throw them out. How about 8? 8 goes into 28 3 times. With 5 as a with 4 as a remainder. Ooh, 8 might work. So let's try 8. So 8 goes into 28 3 times with 4 as a remainder, and 8 goes into 45 times. So 8 times 35, we do 8 times negative 35, and let's add that. Okay, so 8 plus negative 35 is negative 27. Right? So this is it. We found it. Okay, so these are our two factors. Now, watch what I do with 8 and negative 35. Okay, so this is what we want. Let's go back up here. I'm going to write the first term unchanged, but I'm going to give myself some room. I'll write 14k squared. Okay, and now I'm going to split this middle coefficient into 8x and negative 35x because they add together to be negative 27x. But where I put it is very important. All right, so you want to look and see, I have a negative 35 here and a 14 here. They have a common factor of 7, so I want to put 14k squared minus 35x. All right, now that's one factor binomial there, and we're not done with it yet. But now I look at this 8, and I'm going to come up here and do an open parentheses, and I'm going to write 8x minus 20, close parentheses, equals 0. Now, we're not done yet, but just make sure you understand what I'm doing. Okay, so now we have to find the greatest common factor out of each of these little binomial expressions and pull that factor out. So you got to ask yourself, what can you divide out? Just take them one at a time. What can you divide out of 14k squared and negative 35? Oh, I wrote x. I'm starting to switch over to x in my head. These need to be k's, don't they? Because the temptation is always to think in y's and x's. So I might have to check myself throughout this to make sure I don't do that. Okay, so let's see what we can divide out of both. Greatest common factor I can divide out of 14k squared and negative 35k would be like a 7k. All right, so I'm going to put little division symbols here and write 7k and 7k. And I'm not going to put signs yet. We'll come to that in a moment. Now over here, the greatest common factor from 8k and negative 20 would be a 5. All right, so I can, not a 5, a 4. So I can divide a 4 out of both 8k and negative 20. Again, no signs just yet. Now let's do some analysis. If I divide 14k squared by 7k, what will be left? Well, it'll be 2k. All right. And over here, if I divide 35k by 7k, what will be left? 5, because the k's cancel as well. So look over here. If I divide 8k by 4, I get 2k left over. And if I divide 20 by 4, I get 5. So if I do it this way, just like it is, it's going to leave the same result, simplified result, inside the parentheses. So this is like reverse distribution. You're pulling these numbers out. Let me show you what that looks like. So out to the left here, I'm going to write 7k, and then I'll do an open parentheses, and I'll write those quotients that I was talking about earlier. So this is 2k, and then it's minus 5, because 35k divided by 7k is 5. Alrighty. Now, leave some space here, because you're going to write 4, just like that, and then open parentheses. And now 8k divided by 4 is 2k. And then 20 divided by 4 is 5, so it would be minus 5. Now notice something. You have 2k minus 5 inside both parentheses. This is what you want. You have to get this before you move on. And sometimes you have to go back and change the signs and kind of rework it. Sometimes you've even mistakenly put the wrong k value or split middle coefficient value here and here. You'll need to swap them out and kind of start over. But you keep messing with this until you get the same terms inside these little binomial expressions. Now, these represent a single factor of the quadratic, and then these terms together combine to make another factor. So the final factors, we'll do an open parentheses, and we'll write 7k plus 4, close parentheses, open parentheses, 2k minus 5. All right, close parentheses. So those are your two factors. If you were to FOIL that back out, you would get the original quadratic equation. So this is equal to 0. Now to find the solutions to the quadratic, you just set each factor equal to 0 and solve for the variable. So I've got 7k. Again, I'm trying to, as a left-handed person, I wish you could sit in my shoes and see how hard it is not to cover up what I'm writing. 7k plus 4 equals 0. And 2k minus 5 also equals 0. So we're just going to solve for both. These are going to be rational real numbers, so it's going to be fractions. But these are real numbers. These intercepts would be plotted in the real coordinate plane. So let's see what they are. Minus 4 on both sides. Now I have 7k equals negative 4. We'll divide both sides by 7. Cancel out the 7's, and now I have k equals negative 4 over 7. Okay, so that's one solution to the quadratic. Now let's do the next one. First, we'll add 5 to both sides. And then we'll have 2k equals 5. And I'll divide both sides by 2. Cancel out the 2's and get k by itself. K equals 5 over 2. All right, so we have two solutions now. And in order, the way they want us to list it, it's negative 4 over 7, comma, 5 over 2. Now you should always expect these two solutions when you're doing these quadratics. And sometimes they're the same, but there are always two, because the fundamental theorem of algebra says that there are always the number of solutions to a polynomial equal to the highest degree term. So the highest degree term in this quadratic is the squared term, so there are at least two solutions. Now, they might be real, they might be imaginary, non-real, complex answers, but there are going to be two. So keep that in mind, you're always going to be getting two. So we're looking for negative 4/7 and 5 over 2, and I see that here in D. Okay, now let me sector off this half of the page. So we're going to complete the same process here in problem number 4, but we have to start the process by isolating the right side to be 0. All right, so let me rewrite the original quadratic, 5x squared. Again, we're going to solve this by factoring by grouping again, and then solve. Minus 8x minus 24 equals 6x. Okay, and now to get the right side to equal 0, I just subtract 6x from both sides. Okay, so I'll subtract it on the right, and then I'll put that minus 6x. I'll line it up under what's called the linear term of the quadratic, this x term. This is the quadratic term, this is the linear term, and this is the constant term. Okay, and just a quick sidebar, the quadratic, and this is going to be important when we do quadratic equation in a second, but it's always going to be written ax squared plus bx plus c equals 0. This is the standard form of a quadratic equation. So when I'm talking about the a value, I'm referring to the 5, the b value is negative 8, and the c value is negative 24. So if you had wanted to factor it, or solve it rather, using the quadratic equation, which we'll do here in a second, or in a minute, a couple minutes maybe, you need to know what the a, b, and c values are. All right, so they have to be lined up in this particular way, or you won't be able to recognize them very easily. Okay, so a little bit of math here. Nothing happens to the 5x squared, so he just comes down. 5x squared. Now negative 8x minus 6x is minus 14x minus 24 equals 6x minus 6x is 0. Okay, so the question is, do we now have a standard form quadratic equation with 0 on the right side? Yes. Okay, so now our a, b, and c values are 5, negative 14, and negative 24. And you want to multiply a times c in order to find out what your middle terms have to add, multiply to equal. They have to add to equal negative 14 and multiply to equal the product of a and c, 5 times negative 24. So over here in side work, we need to put negative 24 times 5. Okay, maybe you can do it in your head. Okay, so 4 times 5 is 20, carry the 2. And then 2 times 5 is 10 plus 2 is 12. So it's negative 120. So what we're looking for are two numbers, and here's our little table that's supposed to help us. Two numbers that add to be negative 14 and multiply to be negative 120. Alrighty. So now we have to start doing our analysis. And sometimes these are easier than others. Okay, we can skip like 1 times negative 120, right? Let's get into things that might actually add to equal negative 14. How about let's do 8. So let's see, 8 times what equals 120? Well, 8 goes into 12 once with 4 as a remainder, and 8 goes into 40 5 times. So 8 goes into 12 once with 4 as a remainder, so then you have this little 4, and so then you say, how many times does 8 go into 40? It goes in 5 times, so we could do 8 times negative 15, and that'll equal 120, and we could also do negative 8 times positive 15, and that would also equal 120. But do they add to equal negative 14? No. We actually might have overshot the mark here. Let's try 6. Okay, 6 times what equals negative 120? Well, 6 times negative 20 equals negative 120, and 6 plus negative 20 equals negative 14. So here we go, we got it. So this adds together to be negative 14 and multiplies together to be negative 120. So this is we're going to split this middle linear coefficient into two different numbers. So it'll be either plus 6x minus 20x or minus 20x plus 6x. And the order is very important. So what you're looking for is how to choose is you're looking for do 6 and 5 have the greatest common factor? No. But 20 and 5 do, so I'm going to put that minus 20 up front. So here's what I mean when I'm talking like this. I mean, I'm going to say 5x squared minus 20x, okay, and that's going to be one thing. And then I'll have another open parentheses, and I'll write 6x minus 24, okay, and that's all equal to 0. Well, now what? Well, now we have to factor out the greatest common factor from both of these terms, all right? And we picked the right terms in the right order because the binomials share common factors within themselves. So what's the greatest common factor of 5x squared and negative 20x? Well, you should be thinking like 5x, right? Could divide out a 5x from both of these. Over here, the greatest common factor between 6x and 24 would be 6. Okay, so now we're going to pull these out to the left. So out to the left, I'm going to write 5x, open parentheses, and now what is 5x squared divided by 5x? Well, it's just x. And what is negative 20x divided by 5x? Well, it's just negative 4. Close parentheses. And now over here, we'll pull the 6 out. And inside 6x divided by 6 is x. Negative 24 divided by 6 is negative 4. Again, the key is that these two binomials are equal to one another. So x minus 4 and x minus 4 are the same, and we did it right. So now we combine the greatest common factors together to be its own little binomial factor of the quadratic. And we combine, and then we just take one of these, all right, so it's x minus 4. So this is the final factored form of the quadratic. 5x plus 6 times x minus 4 equals 0. If you were to use the box method or the FOIL method to recombine these together and multiply these binomials together, then you would indeed have the original quadratic. Okay, you could try it for yourself. Now we'll set each factor equal to 0 and solve for x. So 5x plus 6 equals 0. And then x minus 4 equals 0. Again, we're going to have these rational solutions here. Rational meaning fractions. Okay, so now I have 5x equals negative 6. And we'll divide both sides by 5. Cancel, cancel, and now I have x equals negative 6 over 5. That's one of my solutions, and the other solution will be an integer solution. I'm going to add 4 to both sides, and now I have x equals 4. All right, so in order from least to greatest, my solutions are negative 6 over 5, comma, 4. Okay, that's two real solutions to the quadratic that crosses the x-axis at negative 6/5, comma 0 and 4, comma 0. The quadratic has a y-intercept of negative 24, and its leading coefficient is positive, so it slopes up. So let's look for negative 6/5, comma 4 up here, and we get it. So a pre-AP student should not look at the answer choices until they know what they're looking for, and so I don't ever look at them. Don't backplug your answers. Show the work. So on the test, it needs to look like this, all right? It's going to be pretty easy to tell if you've used Mathway or Photomath, or you've somehow cheated using Desmos or something, because you just wouldn't have, especially these little trials, you would not have these trials if you just copied it. So just take the time to learn how to do it. All I'm trying to do with this is prepare you for Algebra 2. That's the goal. It's not a torture exercise, although these problems probably look like torture exercises. I actually think completing the square is a lot easier than factoring by grouping because it's an algorithmic process, which means that you don't really have to think once you know the process. You just have to do. All right, well, let's do this one. Number 5 says 6v squared plus 12v minus 51 equals 0. All right, so let me show you the whole process for completing the square. You've got to write 6v squared, and I'll just pray that I don't accidentally revert to x, plus 12v minus 51 equals 0. All right? Now, the very first step in any completing the square problem needs to be moving the c value to the other side of the equation. And so you just have variable values on the left side. So we'll add 51 to both sides to move it. And then all that's left is on the left side, I have 6v squared plus 12v, and then equals positive 51. Now, when you complete the square, the leading coefficient must be 1. Right now, the leading coefficient is 6, so I need to divide each term. I need to divide this entire equation by 6. So each term needs to be divided by 6. So 6 divided by 6 is 1, leaving behind v squared, which is what I wanted. I want that quadratic term, the v squared, to be all by itself. 12v divided by 6 is positive 6, or positive 2v. So plus 2v equals 51 divided by 6. Now before we write 51 divided by 6, add 5 and 1 together in your head and you get 6. So 51 is divisible by 3 because 6 is divisible by 3. The sum of the integers, if the sum of the integers of a number are divisible by 3, then the whole number is divisible by 3. So I'm going to go over here in a little side work area and figure out what 51 divided by 3 is. Okay, because I don't know off the top of my head. 3 goes into 5 once, with 2 as a remainder. 3 goes into 21 7 times. Yeah, I never would have guessed that. It's 3 times 17. So what we can write is, we can, instead of writing 51 divided by 51 over 6, right? Because that's what we would get, 51 over 6. The greatest common factor of 51 and 6 is 3, so we can divide both the numerator and denominator by 3 and reduce this fraction down to 17 over 2. Smaller numbers are always better, okay? So over here on the right side of the equation, I'll write 17 over 2. Now what? Well, I'm going to say it out loud and then I'm going to do it. What you need to do now is look at the middle coefficient. That's the b value. That's the coefficient of the linear term, 2. You need to look at that. You need to divide it in half and square that quotient, all right? So divide 2 in half and square the quotient. What is 2 divided by 2? 1. And what is 1 squared? 1. All right, so that's called half the middle coefficient. Half the middle coefficient is 1, and then you square half the middle coefficient, and you get whatever you get. And the other problems won't be as easy. But this one's 1. Now, whatever you get when you square half the middle coefficient, you add to both sides of the equation. That's why I left this big open space right here. All right, you also need to leave this big open space right here. So we'll add 1 to both sides of the equation. But when I write plus 1 over here, I want to write 1 with a common denominator of 2, so I'll write 2 over 2. That way I can combine those two. Okay? Now what? Well, this is factorable, all right? And it's factorable into what's called a perfect square binomial, which means that whatever the factors are, they're identical to one another. All right, so let's think of two numbers that add to 2 and multiply to 1. How about 1 times 1? 1 plus 1 is 2. 1 times 1 is 1. So it's going to be v v plus 1 times v plus 1. Now I want to just show you something. This problem isn't very good for demonstrating this, but when we did half the middle coefficient, we divided 2 by 2 and got 1. That we already knew that our terms here would be 1. So whatever half the middle coefficient is, that's what you're going to put as your constant value in your factors. So v plus 1 times v plus 1 can be rewritten, and this is the key for completing the square, as v plus 1 squared. And that's equal to 19 over 2. Okay? Well, how do we get rid of that squared? Well, we could square root both sides. All right, so that's what we're going to do next. We're going to square root both sides. Okay, just be careful and write this neatly. Take your time. So the square root of v plus 1 squared is just v plus 1. But when I set this equal, I need to always start by writing plus or minus. All right, because there's going to be two solutions to every quadratic. So you have to start by, when you take the square root, there's always a plus and minus. So now it's the square root of 19 over 2. Okay? So we have the square root of 19 over 2. Okay? So when I write square roots, I have the ability, especially when there's a fraction inside, to break up the square root and put square root 19 on top and then big fraction bar and square root 2 on the bottom. Okay, so that's what I'm going to do next. So I'll put v plus 1 equals plus or minus the square root of 19 over the square root of 2. Okay? And now I will subtract 1 from both sides. Okay, so now I have v by itself. V is equal to give me just a second here. I want to make sure I didn't do something wrong. 17. Okay. So this, let me just check. I'm checking my work here because I'm coming up with the wrong answer, and I've got to check my work and make sure I'm doing this right. So 3 goes into 5. Okay, 3 goes into 5 once with 2 as a remainder, and 3 goes into 21 7 times, so 17 over 2. That made sense. So I had 17 over 2. I had divided everything by 6. 6 divided by 3 is 2. So it's fine to reduce the fraction like that. And then I have this v squared plus 2v plus 1. And sure enough, 17 plus 2 is 19. Okay. I'm taking the square root of 19 here. Somewhere in there, I should have been. Okay, I'm going to keep going with it because I actually, now that I'm looking at the answers, I think I'm right about what I'm doing. I just think that the answers are written in a different way. So just checking something. Let me just continue, all right? So now we have to write this. We have to do this, okay? So take a look at this, and then I'll show you what's going on with why I stopped, okay? So I broke my own rule and looked at the answers, which I should not have done. Okay, so we'll put -1 plus or minus the square root of 19 okay, over the square root of 2. Okay? Now, I can see what went wrong here. Nothing went wrong, by the way. It's what we're doing is still correct, but we're going to have to do some extra work at the end. No worries. I'll show you how to do it, and it'll be a learning experience. So now we have v equals, and I need to write -1. Okay, and this is going to reveal a little bit about what I'm thinking in my head. I need to write -1 with square root 2 in the denominator. So that means I have to multiply the numerator and denominator by the square root of 2. So in the numerator, I have negative square root 2, okay? -1 times the square root of 2. So that negative square root 2 over square root 2. Do you see how that still equals -1? And then I have plus or minus the square root of 19 over the square root of 2. Now, the benefit of having done all this work is that now we have a common denominator, so I can write v equals negative square root 2 plus or minus the square root of 19 all over the square root of 2. Because we have that common denominator, all right? So now, just stop here for just a second and go look up at your answer choices. You don't see any of them there. You don't see anything that looks like the square root of 19 is going to be there, right? Okay, well, I'll explain what happened. I'll explain exactly what happened here, and I'll show you how to fix it. Okay, so before we continue, we need to get rid of these two square roots. Okay? Now, how are we going to do that? Well, if I multiply this equation by something, it will cancel the square roots out. Okay? And so that's what I got to think of. What's going to cancel those square roots out? Well, if I multiply this equation on the right side by the square root of 2 over the square root of 2, those square root 2's will cancel out. Okay? So let me show you what I'm going to do. And you're going to watch this. Okay, and I'll tell you what we should not have done earlier after I'm done. So now what I'm going to do is multiply the right side of the equation by the square root of 2 over the square root of 2. So this is some good math practice, and it's the result of an unnecessary step that I took in simplifying and reducing a fraction earlier. Let me just show you why are we having to do all this extra work. When I went ahead and simplified this fraction, that's what caused the problem. I should say I should not have simplified the fraction, okay? I'll admit it, I should not have simplified it. It's not wrong, but it's also not what the answer choices want. So what we've done is correct, but not in the form that they want. So we have to get rid of these square root 2's. So here's what we're going to do. Now we are going to distribute this square root 2 to every term inside the parentheses. Okay, so this is good practice in a way, but it was unintentional. So square root 2 times negative square root 2 is the square root 2's cancel out and leave behind just what was inside the radical. So square root 2 times square root 2 is 2. So we just write negative 2. Okay, then plus or minus. The square root of 2 times the square root of 19 is the same thing as the square root of 19 times 2. Okay? And here I'm making a slight mistake. So this is wrong. The square root of 2, let me do this in side work because talking about it is making me lose my mind. The square root of 2 times the square root of 2 is equal to the square root of 2 times 2. Okay? So this is equal to the square root of 4. Oh, I was right. Which is equal to 2. Okay, well, I was right. Just put this 2 back here. I was right there. And now the square root of 19 times the square root of 2, square root of 19 times the square root of 2 is equal to the square root of 19 times 2, which is equal to the square root of 38. All right. So instead of writing plus or minus the square root of 19, I'll write plus or minus the square root of 38. Okay, all of that will be divided by, again, square root 2 times square root 2, which we already saw as 2. So then in the denominator here, I'll just write 2. Now, this is correct, okay? So what we're going to do is find both of our solutions. So we're going to have V1 and V2. Let me solve V1 first and see what kind of room I have left. V1 will be negative 2 plus square root 38 over 2. V2 will be negative 2 minus square root 38 over 2. Okay, all over 2. So let's do the first one. That's negative 2 plus square root 38 all over 2. There's no further simplification possible. Now v2 equals negative 2 minus the square root of 38 all over 2. So these are our two solutions. Let's go up and see if we have both of these up here in the answer choices. There it is. So C is equal to, the two solutions are negative 2 plus square root 38 over 2, and then negative 2 minus square root 38 over 2, right? By the way, I don't have the answer key for this. I didn't print it out, or maybe I printed it. It's at the bottom of this packet, so we'll check at the end. But these are just the answers I'm getting, and I'm fairly sure that they're right. Okay, so moving on, we will try to avoid these little pitfalls of getting all these square roots like this, but it happens, okay? And it's somewhat terrifying when it does, because you think, oh, I did it wrong, have to start over, should not have written in pen. But in reality, you're right, but it's in the wrong form. Okay, give me just a moment to stack these papers a little bit. So in number 6, our task is to factor this quadratic, and we're going to do it by completing the square. So like I said, I'll try to do this right the first time, but no promises. I'll just write it again, 5b squared plus 20b plus 48 equals 0. Okay? So now, remember what the first step is to subtract the constant term from both sides, or add, whatever you have to do to move the constant term over to the right side. So first we'll subtract 48 from both sides in order to move it to the right side. All right, so now I have 5b squared plus 20b equals negative 48. If I ever had a single clue that I would be making a YouTube video at some point in my life, I would have forced myself to be a right-handed person. This is really hard. Okay, so now what we have to do is get rid of this leading coefficient of 5. And so we're just going to divide the whole equation by 5. And I will not reduce the fraction. Okay? I don't think you can reduce that fraction, but I wouldn't do it if I could. So now 5b squared over 5 is just b squared. 20b over 5 is plus 4b. And then over here we have negative 48 over 5. Okay. Okay. Well, now we can take half the middle coefficient and square it. So what's half this middle coefficient? Well, 4 divided by 2 is 2, and 2 squared is 4. So the half the middle coefficient is 2, and the square of half the middle coefficient is 4. So we're going to add the square of half the middle coefficient to both sides. All right, but when I add 4 to the right side, I'll write it as 25ths instead of 4 over 1, because I need a common denominator. So I'll put 25ths. So 4 is equal to 25ths. All I did was get a common denominator. Now, I can tell you right now that we already know what this factored form is going to be in its squared form. All right, so the first part of the binomial is going to be b, and then you do half the middle coefficient is the other term in the binomial. So half the middle coefficient is 2, so it's going to be plus 2. Guaranteed, if you FOIL that out, you'll get b squared plus 4b plus 4. See, we've created our own little simplified quadratic equation on the left side. Now, negative 48 plus 20 is negative 68. when I see a negative number over here at this point in the problem, I know that I'm going to have imaginary solutions. So negative 68 over, not negative 68, dummy. Negative 48 plus 20 is negative 28. So I know I'm going to have imaginary solutions over here. The question is, what are they? And we'll get to that in a moment. Negative 28 over 5. Okay, so my next step in completing the square is to take the square root of both sides. So I will take the square root of the left side and the square root of the right side. Okay, so this is square root and square root. So the square root of b plus 2 squared is just b plus 2. And that is equal to, remember the plus or minus. And instead of writing the square root of negative 28 over the square root of negative 28 over 5, I'll write the square root of negative 28 over the square root of 5, because I can break up the square root like that. That's legal. So this right here is equal to this. Okay. The square root of a fraction is equal to the square root of the numerator of that fraction over the square root of the denominator of that fraction. So now I'll subtract 2 from both sides. Okay. Alrighty, so now I've got b equal to negative 2 plus or minus the square root of negative 28 over the square root of 5. Okay. Well, it looks like we're going to end up doing some of the same stuff we just did in the previous problem again. Because I need to find a common denominator here with negative 2 and the square root of 5 over here. So I'm going to have to multiply negative 2 times square root of 5 over the square root of 5. So now b equals negative 2 times square root 5 over, oh, well, hold on, plus or minus the square root of 28, negative 28 over all over the square root of 5. So I have this common denominator now. Okay, so they definitely don't want the denominator to have a square root. That's not allowed. So we have to rationalize the denominator by multiplying every term in this equation by the square root of 5. Okay, we got lucky in the last problem because we just practiced this. So we're going to multiply. So this is actually what the solution path to the problem would be, even if you had done it correctly. Okay, so I'm multiplying everything by square root 5 over square root 5. So on the top, I'll be multiplying across by a square root 5, and then on the bottom, I'll be multiplying across by square root 5. So remember, when I multiply two square roots, it's like you're putting both of the radicands, that's the number under the square root, together underneath their own square root. So what this equals, b equals, is negative 2 times the square root of 5 times 5, which, so I'm going to write it out, square root of 25. We can reduce that. Okay, plus or minus, and now I have to do 28 times 5, which I don't know. So 8 times 5 is 40. 2 times 5 is 10, plus 4 is 140. Okay, so it's negative 140 inside the square root. So plus or minus the square root of negative 140. I love problems like this because you really feel like you're doing math, you know. And then on the bottom, I have the square root of 5 times 5, which is the square root of 25. And, you know, as I've learned math over time, I've gotten slower at math. When I was younger, I would solve problems way faster. And now I really take my time and try to write as neatly as possible because there's value in it. So now we can reduce these square root 25s down to their perfect root, which would be 5. So here I'll write b equals, and now negative 2 times 5 is negative 10, so I'll write negative 10 plus or minus the square root of negative 140, which I'll get to in a minute. We're going to have to simplify that square root, negative 140, all over square root of 25 is 5. Okay. Now, what do we do with the square root of negative 140? Well, first of all, we're going to rewrite it as the square root of negative 1. Okay, so you can rewrite the square root of negative 140. That is equal to the square root of negative 1 times the square root of 140. So you can always kind of separate that negative 1 out. Now the negative 1, when you take the square root of negative 1, you're left with the imaginary number I. Okay? So what we have is I times square root of 140. But we're going to be able to simplify that square root by prime factoring 140. So 140, I already know it's 28 times 5. So let me do this. Let me show what I mean by prime factor. I'll do 5 here times 28. And that reduces down to 4 times 7. And then that's 2 times 2. Okay. So I can rewrite the square root of 140. Let me show you this. The square root of 140 is equal to the square root of all of the products, okay, the product of all the prime factors. So that's 2 times 2 times, excuse me, sneezed. 2 times 2 times 5 times 7. Okay? Now, whenever you see a pair of numbers in a square root, they can come out. So the square root of 2 times 2 is just 2. So I'll pull that out as a 2. Square root 5 times 7, which can't be reduced, and that's 35. Okay, so let's recombine what we have. We have I times the square root of 140, so I need to I times 2 square root 35 is equal to 2I square root 35. Okay? So when I go back up here and I rewrite this, you'll hopefully won't be confused as to where all that stuff came from. So now B equals negative 10 plus or minus, okay, now write this whole thing, 2I square root 35 all over 5. Okay, so we have two solutions here. One of our solutions, B1, will be negative 10 plus 2I square root 35 over 5. And our other solution, B2, will be negative 10 minus 2I square root 35 over 5. I wrote square root 36, square root 35 over 5. Okay? Now, how do we interpret these imaginary solutions? Well, here's what I can tell you by just looking at the solutions and the number itself. I can tell you that this has a positive slope because the leading coefficient is positive. So it's sloping upward, the quadratic. I can tell you it crosses the y-axis at positive 48, okay? But here's what I can tell you by looking at these solutions. Okay, because they have an imaginary term, they do not exist in the real plane. So this quadratic equation never crosses the x-axis. That's what I can tell you by looking at this. Now, when we go back up and look at our answer choices, it should, at this point, feel extremely gratifying to be able to circle this one because we never looked at them, all right? And we just followed the math, and we were very careful, and we found out all this. So if you were able to do that, congratulations, it's good work. Okay, moving on. Now, you'll get to do something that is somewhat easier. Actually, it's much easier. But it also takes the kind of analytical fun out of what we're doing. I should say something. When we're completing the square, and I've shown this in many other videos, when we're completing the square, what we're doing is we're starting with a square, okay, that has this, in this instance, it has side lengths of b. Okay, let me just show you what we just did, just so you understand. All right. Look here, it says b squared plus 4b. All right, so this is b times b. The area of this square is b squared. Okay, so then we do plus 4b as like an algebra tile. Okay, plus 4b. Now, if you were my student last year, you've seen this. Okay, so plus 4 times b, and so that would be 4b. What we're looking for now is remember we took half the middle coefficient. So that's essentially the same as dividing this little tile in half. And then we clip this piece, and I'll just show white out, getting rid of it. We clip this piece, and we stick it down beneath the square that has side lengths of b. Okay, so now this isn't 4b anymore. This is half the middle coefficient. This is now 2b. And down here, we're going to draw a congruent rectangle to that little rectangle right there. Okay, it has a width of 2 and a length of b, so its area is 2b. Now what we're looking to do is find the area of this little square right there. Do you see how we have to complete the square? This little tiny square is the completing the square. It's just beautiful that it has this nice visual representation. So that would be side length 2, right? You just copy it from here, and then side length 2. So that would be 4. 2 times 2 is 4. That's so cool, right? So that's how we got plus 4, okay, and plus 4 over here. So that's completing the square visually. Anyway, the reason I went off on that little tangent, which is always a dad joke in math, going off on a tangent, is because the quadratic formula strips all of that analysis and visual beauty and harmony from the process, but it is a more direct approach. So if you have not already, please take the time to memorize the quadratic formula. All right, the quadratic formula says that x, okay, the solutions to the quadratic equation, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a. So that's why it's really important to know what a, b, and c are and to have it set up in standard form before you start plugging it into this formula. If you're trying to figure out how to memorize this formula, I can tell you that when I was in college, my college algebra teacher taught me that to sing this formula to the tune of Jesus Loves Me. You know, Jesus loves me, yes, I know, right? So not a religious lecture. I'm not promoting any religion whatsoever. But the tune, this is what the guy taught me. He said, and this does sound corny, but once you get it in your head, it'll be there forever. I promise you, every time I write this formula, I'm singing this little song in my head. It's very similar to the way we say ABCs, you know, A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. Okay, now I know my ABCs. Next time you can sing with me. Everyone knows that song. So here's how you sing the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. You cannot go wrong this way. Okay? If you sing that to yourself a few times, you will never forget the quadratic formula. So as cringy as that sounds, you probably have hairs standing up on the back of your neck right now. As cringy as that sounds, it will help you, okay? So now that we've written the quadratic formula, let's write the equation that we were given, and we're definitely going to have to reorder terms. So we're given x squared equals negative 10x plus 23. That is definitely not standard form, so we need to move everything over to the left side of the equation. So we'll add 10x, and we'll multiply, or we'll subtract 23 from both sides of the equation. And here I'm just doing these two steps at once because we understand what we're trying to accomplish here. So these all cancel out here. So x squared plus 10x minus 23 equals 0. Now we should identify the a, b, and c terms. So I've got ax squared plus bx plus c equals 0. So the question is, what is the a value? Well, it's 1. There's a coefficient of 1 there. So when we're going to do quadratic formula, we'll just write down a equals, b equals, c equals, like that. And we'll just write it out so we can plug it in. So a is 1, b is 10, and by the way, it would take the sign that goes next to it. So if that had been negative, it would be negative 10. So b is positive 10, and c is negative 23. And we're just going to plug this into the quadratic equation. Order of operations is very important in the quadratic equation. So that's why I don't like it, because little tiny errors in the order of operations will screw up everything. So you got to do PEMDAS when you're doing quadratic equation, big time. So x is equal to negative b. Well, b is 10, so negative 10 plus or minus the square root of, and then put a big thing here, b squared. So 10 squared is 100 minus 4 times 1 times c, so that will be 4 times negative 23, okay, because the 1 doesn't really matter, all over 2 times 1. I just don't even need to write it. 2 times 1 is 2, all over 2. Okay, so let's simplify further. I'm going to have to multiply 4 times negative 23 here. So that's 23 times 4, which I have no idea what that is. 12, 1, 9. It's really 92. Yeah, I guess it is. So let's rewrite. I have x equals -10 plus or minus the square root of 100, which was 10 squared, b squared, 100, minus -92, because, you know, it was -23 times 4. So that is one place where the order of operations would have killed you, because now you have this double negative in here. So it's actually plus all over 2. Okay. Well, moving on. So x equals, we're going to continue to simplify, -10 plus or minus the square root of 192 all over 2. Now we're definitely going to be able to simplify that square root. And that's what usually kills students, is simplifying these square roots, but you've got to prime factor 192. There's just no way around it. So 2 goes into 19 9 times with 1 as a remainder, and 2 goes into 12 6 times. So 2 times 96 is 192. And then I'll break down 96. I happen to know that it's 8 times 12, but let's do it with the 2's, because if we go in order from smallest prime to largest prime, it actually makes life a lot easier. So 2 goes into 9 4 times, and 2 goes into 16 so 2 goes into 9 4 times with 1 as a remainder. 2 goes into 16 8 times with no remainder. So now we can get going really fast. That's 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Okay, so that's the full prime factorization of 192. And when I can circle these 2's that are in pairs. So I've got 3 pairs of 2's. Okay, and then there's just this 1 3 sitting out here. So what I'm going to be able to do is rewrite the square root of 192. All right, I'm going to be able to rewrite that as 2 times 2 times 2 times the square root of 3. Okay, because this is 2 squared, this is 2 squared, this is 2 squared, and that's 3. Okay, so you just multiply them all together under the square root, and you take in the square root of something squared, it's just that thing, and then the poor little 3, he's left inside. So the square root of 2 squared is just 2. Square root of 2 squared is 2. Square root of 2 squared is 2. All right, so the square root of 2 times 2 times 2 times 2 times 2 times whatever, 3, is 2 times 2 times 2 times square root 3, which simplifies down to 2 times 2 is 4 times 2 is 8, 8 square root 3. Okay? If this is something that you're not comfortable doing, please get comfortable, because there is no way to avoid it as you move forward in mathematics. And it's a tragedy that we've, as a school system, we've shielded you from having to do this by handing you that stinking calculator. So let's go back and write this simplified form. X equals -10 plus or minus, and then we're not going to write square root 192, we're going to write 8 square root 3 all over 2. Okay, now notice this, I have 10, 8, and 2. I can simplify this answer by dividing everything by 2. So you can say -5 plus or minus, and then 8 divided by 2 is 4, so 4 square root 3. So our two solutions, we got x1 would be -5 plus 4 square root 3. and x2 would be negative 5 minus 4 square root 3. Okay, so these are my two solutions. Let's go see if they're there. Negative 5 plus 4 square root 3 and negative 5 minus 4 square root 3. Fantastic. That's great. Okay, so by the way, there's a little trick here that I thought I'd show you. This term, this thing right here, b squared minus 4ac under the square root, this is called the discriminant. And if this whole thing inside evaluates to a negative number, you're going to have imaginary solutions. So in a pinch, you can just do this part, and you could have eliminated all the other answer choices because it's a positive root. So it's not going to be imaginary. Only negative square roots are imaginary. So we could have eliminated B, C, and D because we would know for sure, since b squared minus 4ac is not negative, we know that there exist real roots, okay? So that's the answer to number 7, and we'll move on here to number 8. I'm going to carve out some workspace here. So at number 8, we're doing the same thing. We're going to apply the quadratic formula. So remember, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You cannot go wrong this way. You sing that song to yourself sing that song to yourself when you're taking a shower, getting ready for work or something. You will remember that forever. You'll come back and find me when I'm an old man in a wheelchair, and you'll say, hey, I still remember the quadratic equation. Save me a million times. Okay, so let's write what we were given. 8a squared minus 2a equals negative 8. All right, so this is not in standard form. All we have to do is add 8 to both sides. Okay, and we have 8a squared minus 2a plus 8 equals 0. Okay? This is what we're going to stick into the quadratic formula. So we got to do our analysis. This is ax squared plus bx plus c. So we got to figure out what a, b, and c are. And luckily, they're all going to be pretty easy to match up. So we have a, b, and c. And they're all going to be equal to something. So a is 8. B is negative 2. And C is 8. Why did I just write C? C is 8. Okay, so we're going to plug this into the quadratic equation. So here we go. X is equal to negative 2. Be careful, all right? It's going to get you. You got to watch those negatives. Plus or minus the square root of b squared, so we'll write negative 2 squared minus 4 times a, which is 8, times c, which is 8. Okay? All divided by 2 times a, which is 8. So let's simplify all this out. X is equal to positive 2, negative is a positive, plus or minus the square root of, now negative 2 times negative 2 is positive 4, If you stick that in your calculator, it's going to give you the wrong answer, unless you're real careful about it, okay? I'll show you what I mean. Just type in -2 squared. Okay, it says -4, right? That's wrong. What you need to do is put -2 inside parentheses and then square that, and watch this. It tells you it's 4. So this is a snake in the grass, all right? The fact that the calculator has a hard time understanding what you're telling it to do, you need to be smart and you need to do it by hand, okay? Because you'll know that there's no possible way that multiplying two negative numbers together could equal a negative number, all right? So be careful with that. So that's 4. And now we can just multiply all this together. We have 4 times 8 times 8. Well, 4 times 8 is 32. And 32 times 8. All right, we'll do that. What is that? Well, 2 times 8 is 16. Carry the 1. 3 times 8 is 24. Plus 1 is 25. 256. So I have 4 minus 256. Now this is really cool. You already can tell that we're going to have imaginary roots because 4 minus 256 is going to be a negative number. And we'll, it's negative 252, right? So that's, we'll get to that in a second though. But because this is a negative square root, we know we're going to have imaginary roots. For sure. 2 times 8 is 16. So now x equals 2 plus or minus the square root of, now 256 minus 4 is 252, and it's negative, so it's negative 252. All over 16. So we know we're going to have imaginary roots. What we need to do is rewrite this one more time. X is equal to 2 plus or minus the square root of -1 times the square root of positive 252. Okay? Remember in that other problem I pulled that square root -1 out? All over 16. Okay? And I'm running out of space here, so I'll just kind of write it down. It won't be lined up anymore, though. I have x equals 2 plus or minus I, because the square root of -1 is I, and then square root 252, which we'll have to factor and simplify, all over 16. Okay? So now we just have to prime factor 252. Okay, so 2 goes into 2 once with no remainder. 2 goes into 5 twice with 1 remainder. 2 goes into 12 6 times. So 2 times 126 is 252. Can break it down again by 2. 2 goes into 12 6 times with no remainder, and into 6 3 times with no remainder. Okay, and now I've got 3 times 21, and then 3 times 7. So notice here I've got a pair of 2's and a pair of 3's. It's going to be important. So the square root of 252 can be simplified as this. First we have to write the square root of 2. I'm covering my writing up again, sorry. The square root of 2 times 2 times 3 times 3 times 7. Okay, and that simplifies into the square root of 2 squared times the square root of 3 squared times the square root of 7. Well, that simplifies into 2 times 3 times square root 7. And 2 times 3 is 6, so this is 6 square root 7. That is equal to the square root of 252. Okay, that's just the simplified form. All right, so when I go back and write this again, All right, x is equal to positive 2 plus or minus 6i square root 7 all over 16. Okay. And so we can again divide out a 2 from every single term because they're all even. So I can divide out a 2 from all terms and simplify further. 2 divided by 2 is 1, so this is 1 plus or minus 6 divided by 2 is 3. 3i square root 7 all over 16 divided by 2, which is 8. Right, so now I can write my two solutions because we can't simplify anymore. We have 1 plus 3i square root 7, and we have 1 minus 3i square root 7. So these are my two, over 8. In both cases, over 8. All right, so I'm looking for 1 plus 3i square root 7 over 8 and 1 minus 3i square root 7 over 8. Ready? 1 plus 3i square root 7 over 8, 1 minus 3i square root 7 over 8. Wow. All by hand, you know, no calculator. It's better. It feels like a mental workout, doesn't it? Look at all that math. You just feel like you could launch a missile with that. And you could. Okay, so we're kind of switching gears at this point. We're going to solve each system using substitution. Now, this is exactly the same substitution that you're used to. This is linear substitution. So we're moving away from quadratics for just a second, and then we'll do some elimination. So remember, in substitution, the very first step is to make sure that I have one of my variables solved by itself on one side of the equation. So I set these problems up so that you already had one of them solved for on one side of the equation. So we're going to be using y equals 7. Okay. What I'm going to do is recognize that if y equals 7, I can plug that in where there's a y in the second equation and solve for x. So that's what I'm substitute y. So I'll write out negative 8x minus 7 times 7 equals negative 17. Okay, and I should say here, remember that the solution to a system of equations can be graphed as the place where the two lines cross. Okay, so these are two lines. One of them is a perfectly horizontal line passing through 7 on the y-axis there. And then you have this messy looking term here, which now that I'm looking at it would be like a positive sloped line with, no, it would be a negatively sloped line. The slope would be negative 8 over 7 x and then minus 17. So it would be y equals m. So it would be a negatively sloped line. So they would cross somewhere. We're going to find out where these two lines cross. But first we have to solve for x. So let's just proceed. Negative 8x, 7 times 7, 49, minus 49 equals negative 17. Okay, so then we add 49 to both sides. And now we have negative 8x equals whatever 49 minus 17 is. More hard work. 7 from 9 is 2, and 1 from 4 is 3. Okay, cool. So it's a positive 32. And then we'll just divide both sides by negative 8. Cancel, cancel. So 8x equals negative 4. Well, now we can plug that back into our second equation. So we'll substitute x now with negative 4. So now I've got negative 8 times negative 4 minus 7y equals negative 17. And this time I'm going to solve for y, okay? Well, negative 8 times negative 4 is positive 32 minus 7y equals negative 17. Well, now I'll subtract 32 from both sides. Oh, good, I can add over here on the right. Now I've got negative 7y equals, let me add these negative numbers, negative 9 and 4, negative 49. Oh, cool, so there's going to be an even quotient. Awesome. So now I'll divide both sides by negative 7. Cancel, cancel. So y equals negative 49 divided by negative 7 is positive 7. Okay, so now when I write these solutions, they really do represent x and y coordinates. Okay, so the solution to the system is going to be x comma y. So on a coordinate plane, these cross at negative 4 comma 7. And you ask yourself, what quadrant is that in? That is in Q2. Okay, that's in Q2 because the x value is negative and the y value is positive. So I'm looking for negative 4 comma positive 7, and it's D. Awesome. Okay, so number 10, a little bit more challenging because y is solved for a term that contains x. So it's not just a whole number. Okay, so what I'm going to do is substitute y with this. All right, because y equals negative 2x minus 5, I'm going to go up here and plug that into where I see y. That is substitution at its finest. So 4x minus 6, open parentheses, negative 2x minus 5, close parentheses, equals 14. Well, let's do 4x. Now, negative 6 times negative 2x is positive 12x. Negative 6 times negative 5 is positive 30. Equals 14. Okay. Combine like terms. 4x plus 12x is 16x plus 30 equals 14. All right, so now I'll subtract 30 from both sides. Now I have 16x equals 14 minus 30, which I'm just not comfortable, guys, with doing this in my head because I don't want to make the stupid mistake. 4 from 10 is 6, 1 from 2 is 1, and it's negative, so negative 16. Oh, okay, I should have seen that. Sorry, negative 16. I'm getting a little tired here just talking. So I already recorded over 2 hours of video today, back to back. So now I'm adding another hour and 38 minutes so far with this video, so I'm starting to get jumpy. All right, so now I have x is equal to negative 1. So if x is equal to negative 1, I can find out what y is equal to by substituting in my second equation. Y is equal to negative 2 times negative 1 minus 5. So y is equal to 2 minus 5. So y is equal to negative 3. Okay, so my solution where these lines cross is at negative 1, the x value, comma, the y value of negative 3. So where is x and y both negative? That would be quadrant 3, wouldn't it? Yep. So this is a Q3 cross point. So the reason I keep going back to the quadrant thing is if you were having to solve this by graphing, you would want to make sure that your points were in Q3. So it's negative 1, negative 3, A. Now we'll solve each system by elimination. Now remember, elimination always seems to be a little bit easier than substitution. I don't know why. I like them both about equal. Now, In order to solve a system by elimination, you have to have common coefficients. So the coefficients have to be identical in front of one of the letters. And if I look here at my two equations, I don't see any of them have a common coefficient. So I don't see that these x's have common or these y's have common. So I have to do something to these equations before I can actually use them, okay? So what does that really mean? It means I have to multiply something by the top equation, and in this case, something else has to be multiplied by the bottom equation, all right? So that one of the terms is equal. And I think we should use, let's eliminate y, okay? So if I wanted to eliminate y, I would multiply the bottom equation by 5, and I would multiply the top equation by 2. You see, because if I did that, they'd both be 10, right? And it would be 10, positive 10y on top and negative 10y on the bottom, and then I would eliminate by addition, okay? So let's just multiply through. We're going to distribute multiply the 2 through the top equation and the 5 through the bottom equation. So 2 times negative 10x is negative 20x. We're going to have to rewrite both of these. Negative 20x plus 10y equals 60. And negative 35x minus 10y, I'm not writing the y, minus 10y equals negative 5. Okay? So now I can eliminate by addition. See, 10y plus negative 10y is 0. So we are eliminating the y. So negative 20x plus negative 35x is negative 55x, and that equals 55. All right, so divide both terms by negative 55, and we get x equals negative 1. Okay? And what we want to do is just plug that back into one of our original equations and solve for y. So now I'm going to substitute x. Let's substitute x in the bottom equation. So I'll write negative 7, open parentheses, negative 1, close parentheses, minus 2y equals negative 1. Well, negative 7 times negative 1 is positive 7, minus 2y equals negative 1. Subtract 7 from both sides, and we get negative 2y equals negative 8. Divide both sides by negative 2, and I get y is equal to 4. So x comma y is negative 1, comma 4. C. Okay, so now we'll do this one. I'm going to have to do the same thing, right? Both of the equations have to be multiplied by something. And I guess this time, just to change things up, I'll eliminate x. So I'll multiply the top equation. How can I be clever here? I'll multiply the top equation by a negative 7. All right. And that will make that top term positive. And I'll multiply the bottom equation by positive 5 to leave that bottom term negative so I can eliminate by addition. It's just easier. Now, let's distribute and rewrite. So negative 7 times negative 5x is positive 35x. Negative 7 times negative 6y is positive 42y. Okay, and I have absolutely no idea what negative 7 times 13 is, negative 13, so we'll do 13 times 7. 129, it's 91. So negative 7 times negative 13 equals positive 91. And then down here, 5 times negative 7x, that's negative 35x. So those will eliminate by addition. 5 times negative 9 is negative 45y. And 5 times negative 20 is negative 100. Okay? We can eliminate by addition. So these x's eliminate here. And now I have negative 3y equals negative 100 plus 91. What is that? Negative 9? Negative 9. So now we'll divide both sides by negative 3. Y equals 3. Okay, so now we know that y equals 3. We'll just substitute it back into either the top or the bottom equation. I want to work with the 13. So, well, it wouldn't really matter, would it? So we'll just do the top equation. So I'm going to substitute y in the top equation. Negative 5x minus 6, open parentheses, 3, close parentheses, equals negative 13. All right? Well, that's negative 5x minus 18 equals negative 13. And now I'll add 18 to both sides. Okay, cancel those, and now I have negative 5x equals positive 5. Can divide by negative 5. Cancel, cancel. X is equal to negative 1. Okay, so y is 3, x is negative 1, so my solution to my system is negative 1, comma 3. That's D. Okay. Okay, we're done there. And now moving on, we're going to sketch the solution to each system of inequalities. All right. So we have to get these in slope-intercept form. But if we multiply or divide by a negative, we have to flip the sign. All right. So just a quick review. This symbol here is greater than or equal to. And what it means is we're going to have a solid line with filled in dots if we have to plot, and shading goes above the line. Okay, because y is greater than. This symbol here is less than or equal to. Same thing, solid line, shaded in dot, but we're going to shade below the line. Okay, now greater than all by itself is going to be a dotted line. Sorry, you can't really see this. A dotted line, open circles, and it's going to be shaded above. And less than, we have a dotted line as well. Open circles, but shaded below. So those are your 4 possible situations that you'll encounter. Now remember, when if we multiply or divide by a negative number, we have to flip the sign. So let's go down here and get this thing. Well, I guess we can just do it up here. We have to get this thing in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So I have x minus y greater than or equal to 1. Well, I'll subtract x from both sides. Okay, so now negative y is greater than or equal to negative x plus 1. Now, we're going to multiply the entire equation by negative 1, which means we'll have to flip the sign. So now positive y is less than or equal to positive x minus 1. We just changed all the signs. So let's let's look at our other one, and we also have x is greater than or equal to 2. So both of these, if we refer up to our little chart, this is what this one's going to look like, and this is what this one's going to look like. Let's take the first one. We have a y-intercept at -1, and a slope of the x coefficient is 1 over 1, so rise 1, run 1. We start at -1, and we go up 1 over 1, up 1 over 1. So it's going to be a positively sloped line with a filled-in dot, okay? So I'm just able to instantly eliminate B and D because those lines are dotted, and we want solid lines. So here I see I have -1 as my y-intercept for this positively sloped solid line. And I go up 1 over 1, I'm back on the line, up 1 over 1, I'm back on the line, up 1 over 1. This has a slope of 1. Okay? And x is greater than or equal to 2 is a solid line graphed right vertically through 2 on the x-axis, and we would be shading below the line, okay, on this slanted line here, and to the right of the line, okay, greater than x is 2 and less than x minus 1, okay? So this shaded region here is the answer, and so the answer is A. Okay. Now on number 14, we'll have to solve both of these for y. So let's just take the first one and go ahead and get it done. X plus y greater than -2. Subtract x from both sides. We have y greater than -x minus 2. Okay, so that's going to be greater than is this symbol here. So dotted line, open circle, shaded above. Now let's do the second one. 3x minus y greater than -2. So I'll subtract 3x from both sides. -y greater than -3x minus 2. We're going to have to multiply every term by -1 to change that -y into a positive y. Flip the sign. Now it's less than positive 3x plus 2. So these are my two lines. I'm looking for a negatively sloped line with a y-intercept at -2 shaded above. Here down here I've got a negatively sloped line with a y-intercept at -2 shaded above. And then in the second one, I'm looking for a positively sloped line, y-intercept at +2 shaded below. Here I have a positively sloped line with a y-intercept at +2 shaded below. So the solution to the system of linear inequalities is that the places where both of those regions would be shaded. Okay? So it's D. And they both have, they both are going to be dotted lines because it's greater than and less than. So that's how. The way that I did it. So k equals 9 plus square root, and then 3k minus 27. So what they did in the problem is they subtracted 9 from both sides, and they got k minus 9 equals square root 3k minus 27. So I think my mistake was I attempted to square both sides, but I can't do that with this term over here. So that little mistake is what cost us all of our pain. All right, so we have to square both sides like that. And then this becomes its own little quadratic because it's k minus 9 times k minus 9. Right, so that's k squared minus 9k minus 9k plus 81. So that's k squared minus 18k plus 81 equals 3k minus 27. Wow. Talk about feeling like an idiot. So now I'll subtract 3k from both sides. And I got k squared minus 21k plus 81 equals negative 27. Add that to both sides. Now I've got k squared minus 21k plus 108 equals 0. Okay? So I'll try to do this by prime factoring it. All right. Wait a minute. So 2 goes into 5 2 times with 1 as a remainder 27. Okay. 3 times 9 and then 3 times 3. So we've got 1 and 108. Okay, they have to add to be negative 21. So let's see. This is going to be 1, then 2, then 4, then 2 times 2 times 3 is 12 times 9. Do these two add to be negative 21? Negative 12 plus negative 9 is negative 21. So we can factor the quadratic as k minus 12 times k minus 9. So your solutions are k equals 12 and k equals 9. What a joke. All right. What a mistake. Sorry about that. That was a tremendous waste of time. But I guess we learned something. You have to isolate the square root term on one side of the equation, and then you can't just blast each term with that 2. That was entirely wrong. That was just bad math. Here was the mistake, okay? This is no good, okay? This is no good. And so everything, this is fruit of the poison tree down here. All this math was correct, but this was all wrong up here. So we just got screwed up. So the correct math is right here. Wow. All right. Well, I feel chastened and humbled. I'll try to put time codes so you don't get that happening to you. Now on this one, I don't think we'll have that problem. So I have the square root of, this is number 16, the square root of negative 32 plus 12n equals n. Okay, so I've got to square root both sides of the equation like this, not all at once. I've got to square both sides of the equation like this. So on the left side, it's negative 32 plus 12n equals n squared. Okay? And now I'll reorganize this so it looks like a quadratic equation. Let me start by doing minus n squared on both sides. So now I have negative n squared. Let me reorder plus 12n minus 32 equals 0. All right, so now let's change all the signs. All right, it's the same thing as multiplying everything by negative 1 so that this leading coefficient is just 1. So there I have n squared minus 12n plus 32 equals 0. So let's try to factor this directly and just save ourselves some time. So I got to find two numbers that add to be negative 12 and multiply to be positive 32. Okay, so it's going to be two negative numbers. So 8 and 4, negative 8 and negative 4. So it's going to be n minus 8 and n minus 4. Does that work? So the solutions are n equals 8 and n equals 4. So it's 4 comma 8, like this. Or 8 comma 4, right? So it's D. Well, that was easy. Okay, and now we're on to polynomial division, which isn't as hard as it looks, all right? It's actually pretty easy. So let me show you how to do this. N cubed minus 5n squared, I'm just rewriting it, minus 9n plus 27 divided by n minus 6. Okay? So what you have to ask yourself is, what would I need to multiply by n to make n cubed? And the answer is n squared, right? So you put an n squared right here, and multiply n squared times this. So n squared times n is n cubed. Write that here. N squared times negative 6 is negative 6n squared. Okay? Now, you're going to change these signs and add. All right? So now you've gotten rid of this term, and you're going to have n squared all by itself. All right? And now you, what do you do now? You bring down the next term, negative 9n. All right, and so now you're asking yourself, what would I need to multiply by n squared, or by n to make n squared? Well, I need to multiply n, right? So it's plus n, and then n times n is n squared, and n times negative 6 is negative 6n. So remember, we change the signs down here, and we add. So this goes to 0, and now I have negative 3n plus 27. Okay, so now you say, what do I multiply by n to make negative 3n? And you'd say, well, that would be negative 3. Well, negative 3 times n is negative 3n. Negative 3 times negative 6 is positive 18. Remember, change the signs. And you're left with this remainder of 9. Okay, and what that is that's 9 over n minus 6. All right, so what this quotient is n squared plus n minus 3 plus 9 over n minus 6. It's pretty neat, right? So n squared plus n minus 3 plus 9 over n minus 6, right here, A. Okay, number 18, we're going to do the same thing. So we'll just rewrite it here, x cubed minus x squared minus 15x plus 28 divided by x plus 4. So you'd have to multiply x squared times x to make x cubed. X squared times x is x cubed. X squared times 4 is plus 4x. Squared, plus 4x squared. And now I have to change the signs and add. Okay, so these cancel, and now I have negative 1x squared minus 4x squared, and that gives me negative 5x squared. Bring down this minus 15x, and ask yourself what you would need to multiply by x to get negative 5x squared, and it would be negative 5x. Well, negative 5x times x is negative 5x squared. And negative 5x times 4 is negative 20x. Okay, draw a line, change the signs. Negative 5x squared plus 5x squared is cancels out, and now you have negative 15x plus 20x is positive 5x. Bring down the 28, and ask yourself, what would you need to multiply by x to get positive 5x, and it would just be plus 5. 5 times x is 5x. 5 times 4 is 20, positive 20. Draw a line, change the signs, okay, and now add. So now you have a remainder of 8. So your quotient is x squared minus 5x plus 5 plus 8 over x minus 4, or x plus 4, okay, the divisor. So that's what we're looking for. X squared minus 5x plus 5 plus 8 over x plus 4. X squared minus 5x plus 5 plus 8 over x plus 4. It's C. Okay, number 19. There's only 20 problems, so we're almost done. A triangle has a height that is 26 less than 4 times its base. The area of the triangle is 90 square meters. What is the height of the triangle? Well, to do this, it would really help to draw a triangle. And it doesn't have to look like anything. You just have to kind of draw a triangle so you can label it. You don't really have to do this, but it helps me. And we don't know that it's a right triangle, all right? But we know that the area of a triangle is equal to base times height over 2. All right, so that will come into play here in a second. Now, a triangle has a height that is 26 less than 4 times its base. So if its base is x, then that would be 4x minus 26. Okay? So base times height divided by 2 has to be the area, and we know that the total area is 90 square meters. All right? So think about it this way. Base times height, x times 4x minus 26 divided by 2 has to equal 90. All right. So now we'll distribute on top, and we get x, or we get 4x squared minus 26x all over 2 equals 90. And so now I've got, I can divide a 2 out of both of these. So I've got 2x squared minus 13x equals 90. Okay. Alrighty. So now we will just factor this quadratic. Okay. So we need 2 numbers. Let me move this 90 over. So minus 90 on both sides. I've got 2x squared minus 13x minus 90 equals 0. Okay. So I want to try to factor this. And what we're looking for are 2 numbers that add to be negative 13 and multiply to be negative 90. And I don't know that there are 2 numbers that do that. So I'm going to use the quadratic equation. Uh-oh, my headset is dying. I'm going to have to cut the video here. So let me cut the video here, and I might have to come back in another video to finish this because I've literally run out of battery on my headset.